we're looking at code once, deploy everywhere. Can it be that simple? I'm Becky Worledge. I work for the Qt company. I'm in the professional services in Santa Clara in California. I've been there for about 4 years. Before that, I was in professional services up in Oulu in Finland. So I've seen a good amount of people running Qt cross-platform and running it on various different platforms. So I know a little bit about it. Before we start, is anyone using Qt in a cross-platform kind of way now, or is anyone, a few people? Okay, what we're looking at here, we're going to look at a few of the applications or a simple application running across several platforms, kind of a more open kind of discussion about what kind of issues you might face with each platform. Most of them are fairly straightforward, and then we'll take a look at the financial side of how it works and why it's a good thing. Okay, so I guess you're already familiar with Qt and you already know that we solve many of today's issues and we turn up basically everywhere already. We're on smart TVs, we're on boats, we're even on Teslas, although that's actually an earlier version of Qt. But we are all over the place in the automotive industry. We're on a lot of vehicles already. 5,000 customers are using Qt at the moment. Here are some of them. I've even dealt with some of them before, so that's good. And we appear on desktop. Now, one of my friends in the support team in Santa Clara told me that the amount of people using Qt on desktop vastly outnumbers the amount of people using Qt on embedded. So the ability to run on various desktop platforms on a Mac like this one, or on a Windows machine shouldn't be underestimated. It is pretty important. Do we have anyone doing that here by any chance? Yes, super. We're not going to look into this too much, but this is an example application, Tableau Business Intelligence and Analytics have written a glorious user interface using Qt, and it now runs on numerous desktop and other platforms. So it's very simple to do. We're also getting fairly big in the factory machine and automation industry. If you are by any chance at the Qt professional services stand, it's actually hidden in the middle behind kind of a tent thing. But if you go and look at that, they see it. There's a nice demo which I will refer you to for cross-platform because that's running on a MCU as well as Raspberry Pi. So worth taking a look at, worth talking to them. Okay, and of course, we're all over the place in consumer electronics. We're pretty big for IoT and all sorts of things, coffee machines, scanners, so on and so forth. Okay, 3 minutes in, oops. So we'll take a look at the idea of code once and what do we mean when we say code once. Of course, when we talk about code once, we're kind of talking more about cross-platform kind of side of things. So the ability to run an application, you code it once and you can then target it for many, many platforms without changing the code. There's been some discussion over in California in the Bay Area about whether cross-platform is actually a good thing or if it's actually not such a good thing. But of course, that's mostly about the mobile app industry. So if you're talking about cross-platform as in mobile apps, it's maybe not always good because they're kind of written in HTML and they're not in native code. Of course, Qt, the Qt framework is written mostly in C++. So of course, C++ compiles to native code and it compiles fairly fast, pretty quick platform to run. And that raises the question, is C++ itself, the programming language, is that cross-platform? In a sense it is, in the C++ will run on any compiler, but when we're talking about platforms, at least for the Qt world, we're not really talking about basic C++ applications, we're really talking about the operating system and integrating well with the operating system, with the UI elements, the widgets, and so on and so forth. Qt itself was actually created, don't know if you know much about the history of Qt. It was created in Oslo to provide a cross-platform solution in the Norwegian health industry. So Qt has always been cross-platform right from its very start. Of course, as we're a C++ framework, Qt runs pretty fast, pretty good. It's a single native API that will wrap the platform APIs, which will give you the common interface for everything you're possibly doing. And I think in a very real sense, when you're writing a Qt application, you're not targeting a platform like Windows or Mac. You're actually targeting the Qt platform itself. So you would be writing it with the Qt API. That being said, of course, not all platform works the same. Different platforms, especially when you support as many platforms as Qt does, different platforms have different features. So mobile phone, for example, you've got all sorts of things on there which you don't have on a desktop or a laptop. A desktop, of course, perhaps a bit unfair to say a desktop is just an abundance of processing power, but you can do a lot more, a lot quickly in most cases on a desktop. I work a lot with embedded devices, so I know that embedded devices are these days quite powerful, but they are specialized devices. You could almost say it's a general purpose computer without a keyboard. They tend to be specialized. Web applications are a new thing. So is anyone familiar with the WebAssembly framework at all for Qt's WebAssembly? A couple of people. I think they're all wearing Qt t-shirts. So WebAssembly is a new platform which has just kind of come into its own this year. WebAssembly allows you to run an application, download it over the web. It will then compile and run in the browser. We'll take a quick look at that as well. Of course, WebAssembly, it's not so quick for reading from the disk, but otherwise it's pretty good. Has anyone looked at our Qt MCU yet? Super. MCU is a very much more specialized device. We'll take a very quick look at that later on, but we're not going to go too much in depth on that right now. Okay, so cross-platform support is challenging. When you're writing a cross-platform application, if you're not using Qt, then you're going to be, you can either write the same application multiple times, or you can write it for the Windows API and then for the Mac and so on and so forth. You can add the if-defs in your code if you need to. And then you can use a build system like CMake, for example, that will compile and target the application or the platform you're targeting. Again, you need to support different libraries. Some same libraries on different platforms will have completely different names. Otherwise, it will be the same name, and you can generally set it up for that. And so on and so forth. There's various different things you need to do to run cross-platform. And at the Qt company, we know all this very, very well, of course, because it's what we do. And Qt will do pretty much all of this for you. So you see, using Qt, you've got platform-specific libraries, platform-specific includes, CMake and QMake for the cross-platform tool support. I'm going to say world-class IDE. Of course, by that I mean Qt Creator, which is a fantastic IDE with all the tools fully integrated. I think probably you're all familiar with Qt Creator already. Okay, in the Qt library itself, we use the private implementation pattern. That's something which you can also use if you're writing your own. That's very kind of more deep kind of programming. You probably wouldn't do that. We also have the QPA you see in the Qt platform abstraction layer. It's not something you generally need to look at, but, and so on and so forth. We've been doing this for a while, so we even provide an if-def API that you can use if you need to. So Qt will make your cross-platform development, will make it simple, consistent, and fairly straightforward. For most cases, you can write actually your entire application using the Qt framework. And our Qt toolchains will support you when you go off the edge and stop doing that, or write specific code for one specific target. In most cases, for desktop and mobile, you wouldn't really need to worry about this, but I think on embedded Linux, we see that a lot, where you're using the more deeper platform-specific API. So yeah, we can help you with that as well. Okay. Qt, I'm going to mention the Qt API as well. If you're using Qt to target one specific platform, we offer numerous APIs, all of which are cross-platform. We have widgets, Qt controls, HTML, and Qt Ultralight QML. If you've looked at Qt Ultralight yet, the MCU platform, it's a subclass of our QML layer. We'll take a quick look at that later on. Okay. So again, Qt makes the C++ a lot easier to work with. So if you're familiar with the C++, raw APIs are Qt API offers you a whole various bunch of useful features. We have reference counting, smart pointers, and more. A little look at the QThread there. Of course, QThread is probably one of the more different between platforms. So for Windows versus a POSIX compliant platform, we use completely different code on the inside. Okay, how are we doing for time? So let's take a quick look at what platforms we're currently running on, where you can run Qt, and there's a lot. It's actually difficult to count how many platforms we can currently run Qt on because there's a lot. We have these officially supported platforms here, so Linux, Mac, Windows, basically all the desktop, Android and iOS, Universal Windows, and of course embedded Linux in various different ways, either with Yocto or with a more lower level kind of operating system specific one. So the boot to Qt port we have, of course, is Yocto. And we're also supporting Integrity and QNX quite well, and VxWorks, if anyone's using that, we support from version 5.5. These ones, when I say supported, of course, when we say Qt supports such and such a thing, we can mean either Qt runs on a platform or we have a support team who will answer your questions on that platform. So in this case, these are the ones which our support team will help you out with should you need them to. Has anyone looked at the Qt source code for the platforms? Yep. If you look at the make specs we've got in the Qt support team, Qt platforms, we support a whole bunch of them. You need to be a little bit careful with these because we don't actually test them. So although we have GNU Herd there, I'm not sure we've actually run on it for a while, but we do provide a make spec for it. Of course, Qt is open source, so you can take the source code and you can run it pretty much anywhere you want to, given the time. You can do pretty much anything you need to. And from that, we have various community ports which are available. So Open Solaris, Haiku, WebOS, some of the more better known ones. I'm not sure if anyone's using MIMO anymore, but it's still known. Of course, Mentor Graphics have created their own Qt port. If you were at the Qt World Summit last time, it was in San Francisco, we had Qt running on an Android Wear application there, but it's a community port. Okay, any questions? Okay, so I think next we'll take a look at a sample application I have. So I have this fairly simple sample application, which I'm going to run across a couple of platforms and give you an idea, and then we can see what we need to look at. So I'm going to start off running this on this Mac directly. Did it just change it? Okay. My laptop is working. Yes. Okay, so I've got this very, very simple, cute, quick application to show. It's actually using a canvas behind the scenes, so it's not terribly complex. If we take a quick look at the code, we can see that it's actually got this little data class in the background. My thing isn't scrolling. Oh, I see, yeah. So a very simple application, and we can see that they're running here on the Mac. So taking exactly the same code, I can also run that application in a WebAssembly. So I've got a WebAssembly demo here. It's actually running on this machine via a server. You can try it, connecting to it if you want to see it running on your phone. But the simple little demo of the same application. This is running in Safari, so it's downloading it from the server. Is anyone connecting there? No? Okay. So that's our WebAssembly demo, and the difference between these two applications from the Qt perspective is they're exactly the same. So one of them is written using WebAssembly, and the other is using the Qt Mac, the Mac API directly. There's a few differences in the code, but nothing significant. And And I think when you're running on Mac, it's fairly straightforward. You just need to run it, and it goes. Oop, there's a mouse. Yeah, there's a mouse area. Okay. But when you're running on WebAssembly, of course, it's actually statically linking the whole of the Qt library. So I think this WebAssembly demo is about 13 megabytes, which you'd need to download. So it can take a while, and then, of course, it's compiled directly in the web browser itself. Okay. The same application will also run on an iPhone. So if I get hold of Xcode here and then just push it to my phone, it should, given time, it will appear on here as well. So there we have the same application running in more or less the same way on the iPhone as well. Okay. Again, to get it to run on the iPhone, a fairly simple, fairly small application doesn't take much. If you had a bigger application, it would maybe need to consider the size of the application you're running. I think the biggest difficulty to get it to run on iPhone is, of course, the code signing, which these days is a lot easier than it used to be. So it's fairly straightforward. Okay, I also have here a Windows machine, as you can see. Can you actually see the text in the bottom there? I think it's quite small. If I just run this here, it should appear on the display as a Windows machine. Give it a second. Now, when I wrote this demo, I've broken it. Yeah, there it is. There's the Windows port running kind of exactly the same, a very simple QML application. In this case, it's running as a sawtooth pattern. As you can see, I changed the code slightly for the Windows version. So we use these if-defs here. My Qt Creator on Mac isn't scrolling. I think it's because of the display setup. I also have this connected to this Raspberry Pi, which you might see just in front of me. And again, it's a fairly straightforward process. What I've done is I've installed boot2Qt on this Raspberry Pi and connected it up using Qt Creator's kits and device framework. So if we look at the kits, you can see here there's the Raspberry Pi, and somewhere there's the devices. You'll see the actual Pi itself. I've actually can't see anything on my display from here, but if I just push this here, you should see it will appear on the Raspberry Pi given time. So this is nice. This is using a boot2Qt kind of built-in feature wherein we're pushing this over Wi-Fi to this Raspberry Pi, although it's connected to my MacBook. It's actually connected via Wi-Fi. So let me just check if that's working. And so we have the same demo kind of appears here. So this is all fairly straightforward cross-platform deployment. As I say, this is a very simple demo. Unfortunately, the demo was not simple enough. I actually didn't get hold of a Qt MCU and a Qt MCU build until I think it was last week. And it turns out that the canvas is not running on the Qt Ultralight yet. Told it will be given time, but it's not there yet. So this demo itself does not run on a microcontroller. Is anyone interested in Qt on MCU? You should be, because it's fantastic. It's a brand new platform. It's really just come out now. It's in version 0.1.0. As I said, Qt on microcontroller, Qt MCU is running a subset of the QML API. I think it's going to grow over time, but at the moment it's fairly simple. We're using what they call a bare metal runtime. There is actually no operating system on Qt MCU. So as I mentioned, or as I kind of defined at the beginning of the talk, when we talk about a platform, we're kind of talking about an operating system. But when we're running on something which doesn't have an operating system, things become somewhat different. The bare metal system. And it makes the cross-platform question a lot more complex, because if you're looking at the WebAssembly versus the MCU, getting the same application to run on the two, slightly different approach. And From a QML point of view, it's not so different. Mostly it's kind of the same, other than the reduced API, but works more or less the same. You can run fairly easily something on an MCU on a WebAssembly. When it comes to the C++ backend, then things get more different. If you're using a Qt object-based, Q object-based connection to the Qt Quick, then it's not always going to run the same. Any questions on this so far? Aha, yes.
A question about the using Qt on an embedded system.
Aha, yeah.
Why do you not use any of the embedded operating systems? For embedded systems, you want to interact with an external device. Say something connected over I2C. Having the support of an operating system is actually helpful.
For Qt on MCU?
Well, I mean, if you're building an embedded system,
yes.
Product-based embedded system, typically you will have other devices connected as well.
Yeah.
Typically it's the I2C.
Yeah.
And if that is the case, then having an operating system like mbed would be helpful. So is it possible to have mbed, say, interacting or coexisting with
the operating system? Yeah, I think probably I did maybe not make that quite clear enough. So on an embedded Linux system or a QNX or an Integrity or whatever one of our embedded systems, then of course you do have the operating system, and we do work fairly well with I2C, pretty well with I2C. So it's only really when you get to some of the ports we run on. So on embedded, we do run mostly with operating systems. Our Qt from microcontroller is a new platform. Microcontroller itself doesn't have the operating system. It's the bare metal operating system. I'm still learning about microcontrollers. I don't know that much about how they work and how you program them. So I did have this conversation with Arundam Jana, and he explained to me that the operating system isn't necessary on this. You can actually interact with a whole lot of things using a microcontroller system, the microcontroller approach. So it works a bit differently, but I'm not necessarily the right person to ask on this. But yeah, you don't need the operating system. You can still interact with the I2C I would think, on the microcontroller. In fact, tomorrow at 11 o'clock, Simon Hausmann, who knows a lot more about most things, is going to be taking a deep dive at MCUs, and if you need the question answered, then I would recommend being there tomorrow morning upstairs and discussing it with Simon. Yeah. Where's yeah? Sorry. I think we're supposed to have you have the microphone, so I don't know where Ahmed is. No microphone? Okay. Yeah. Sorry.
So we develop on Windows with Qt, but we target Linux, and each time we have to build it on a virtual machine.
Yeah.
Is it still necessary? Can we build for Linux on a Windows machine?
Yes and no. So are you using boot to Qt or Yocto? Or is it just embedded targets? So I think the problem is not Qt, and the Qt will certainly allow you to do that. I think with building on Windows and running on embedded Linux, the problem is getting the compiler and the toolchain for embedded Linux to run on Windows. So if you have a Linux machine, it's fairly straightforward, but if you actually want to build the whole operating system on Windows, with boot to Qt, as I closed, as I have here, it's perhaps, I think you can maybe see, maybe not, the scaling might be being a problem. See if I can fix that. Yeah, it's not much different. So what I've got here is the boot to Qt Yocto toolchains compiled or cross-compiled on a Linux machine, which we do, I think, up in our office in Finland. And then you can then run that directly on a Windows machine. So you can actually run the compiler and so on and so forth on the window, but the build script itself doesn't run on the Windows target. It needs to cross-compile from a Linux to a Windows machine that can then cross-compile to the embedded Linux platform. So I've lost that of you. Okay. Anything else? No? Okay, so one of the things which we talk about when you're building for Qt cross-platform is that, of course, cross-platform will save you time, it will save you money, especially when you're running on embedded platforms. And don't just take our word for it. We actually queried this with our customers in 2017. We have the figures for 2017. And they actually told us that for the cross-compilation, the use of the cross-compiler did actually meet our return on investment expectations. So 95% of our customers were satisfied with that. 78.2% of developers were made more productive as a result of using Qt. Again, our professional services team who are outside can, if you need help meeting these figures, we're more than happy to discuss it with you in a great deal of depth. But to check that we're doing the right thing and make sure everything is going okay, we actually also in 2018, we commissioned a total economic impact survey from Forrester to see that everything was as good as we thought it would. And they indeed did this research for us. Okay, Forrester interviewed several of our customers using Qt for device creation. This is how many of you are using Qt for device creation? Is it all of you here? Everyone? Not yet. Soon. Okay, so Forrester interviewed several of our customers, companies ranging in size from pretty small to pretty big, 15 to 300,000 employees, and developed a framework for the total economic impact of using cross-platform. They developed this framework, they created a composite company to check out what kind of savings you can get, and they performed an analysis on what kind of return on investment you will get. The key challenges they identified for our customers are supporting multiple code stacks. Of course, you don't want to support multiple code stacks. Performance requirements for the HMI, which we'll look at soon. They also needed a long-term stable partnership, and of course the Qt company aims to provide that to our customers. It's a fact as well that time to market pressures are constantly increasing, as anyone who works in the software business will know that we have less and less time to write more and more code. Things get quite difficult. Okay. Key results from the device creation study showed that the Qt and cross-platform approach will give you a significant reduction in the size quote requirement for your development team. They also provide you with what they call a flexible development environment, and by that we mean when you're using Qt cross-platform, it's fairly easy to change the hardware and it's fairly easy to change the operating system because Qt will just run directly on various platforms. It also lowers the price of your hardware. So the Forrester study showed that you could save maybe 10% on the cost of your hardware against using different frameworks or different coding approaches, because Qt is a very efficient C++ framework and runs quite quickly. And of course, the time to market is considerably less. The composite organization they created provides you with a portfolio of systems representing a multi-billion-dollar business. That's one of the bigger companies, and is handling industrial and automation tooling. So there's a great demo of industrial and automation tooling outside, so do take a look. And they are selling thousands of these devices every year. So thousands of devices is a big amount for any company, there's no doubt. But if you're looking at the automotive business, then a thousands is actually quite small, and Qt also runs there. So yeah, okay. The key benefits they found from the Qt for the development cost savings are that single code stack will require fewer developers and fewer APIs. So a single API, it's a good saving. Fewer developers, you can then deploy them elsewhere. Of course, you save with the software development cycle being synchronized across various platforms. The development process is easier, so right from the mock-up process to the porting to new platforms becomes a lot quicker, a lot easier. Again, switching hardware and operating systems is a much easier process. Okay, Qt works well on lower-end hardware, as we've seen the MCU. We've got the inexpensive hardware and various other hardwares. So if you're porting from HTML to a Qt Quick application running on native code, then of course we're a lot more efficient as a software platform. Okay. And the other key benefits of using Qt found by foresters were various unquantified savings. So time to market is quicker, single API, and so on and so forth. These were not taken into account in the Forrester report. Okay. Study results. This is the results that Forrester found from using Qt as a cross-platform framework. You see here, we've got the payback after 3 months. So the cost of using Qt, they actually recoup their cost after 3 months. About 3 months, they got their money back. And total benefits over the course of 3 years was 569,000 compared to cost of 146,000. So savings over 3 years were quite substantial from using Qt as a cross-platform framework. Okay. Development cost savings came to 325, hardware 243. Let's take a look at how they made those figures up. So in year 1, they saved 80,000, year 2, 160,000, so consecutively. Every year they're saving money. Again, with the hardware, they're saving money there. So for the development cost savings, we figured you'd need less, or Forrester assessed that you have fewer developers supporting your software. So you save money that way. Again, with the hardware, because the cost of licensing Qt declines with the amount you sell. So for each platform you pay a license on, as you sell more and more platforms, the cost of the license declines. So you would then save money quite substantially with that too. Okay. We also have this algorithm, which you can also take a look at if you're starting out on this and want to get an idea of how much the return on investment you can save, then do have a look at that. It's on our website. You can also download the report. Okay, so that's the basics of the talk. Do we have anything else which we need to cover while you're here? Okay, it's only 5:30, so we finished a bit too quickly. Ahmed saved me.
Yeah, it's 5:30.
5:30, okay.
We still have some time.
We have plenty of time. No?
Thank you. I have one question. What would you say, in your opinion, are the main benefits of Qt over other cross-platform frameworks like Xamarin, for example?
I think, for me, and you're talking to a Qt professional services engineer, Xamarin is a good platform, but Qt, of course, runs in, I think, more places than Xamarin. I'm not that familiar with the Xamarin, how the UI works for Xamarin, but using Qt Quick, I mean, specifically on embedded, Qt Quick is considerably more efficient, I think. I'd have to look into more about what Xamarin offers, but I think the level of platforms which we support is higher. We run pretty much everywhere. I'm not sure where Xamarin runs exactly. Anything else? Okay.
So you showed us the example, that simple example running on various platforms.
Yes.
But this example, of course, is it scales very much for small display and large displays. But if you have an application with buttons and dialog box and stuff like this,
bigger.
how does the Qt framework deal with scaling? You run it on a desktop and then you run it on a small embedded device. Do you have to do a lot of redesign to scale it down, or how much does Qt help in scaling your application?
Yeah, this is if you look at the various Qt layout technologies, so we've got QWidgets and we've got QQuick. Those are the two principal ones for that kind of development. Both of them have a layout management system built in, and both of the layout systems work much the same. So most of the scaling would come from either a flow layout or a grid layout, kind of standard technologies. So yeah, I think the scaling you don't necessarily need to redesign. I think when you're talking about every single platform, so in this case, we've got like a mobile phone and you're running it on something this size as well, then obviously the scaling requirements for the two sizes are very, very different. So I think in most cases for that kind of thing, you would probably need a separate design for the much bigger display compared to a smaller one. But when it comes to similar sized devices, like a 4-inch versus a 7-inch, then the Qt layout and the like will handle that pretty simply for you. Does that answer your question? Yeah, we can. I don't know if I've got a scaling sample here. We've got numerous sort of technologies which are used for scaling. I don't know if this. My Mac's not working. Yeah, give it a try and come and talk to me afterwards as well if you're around this afternoon, and we can go over that in more depth. But there's various different approaches which Qt offers, and they're all pretty robust. Okay. Anyone else?
So a question about the cross-platform element, especially on the desktop.
Mm-hmm.
So I'm a manager, not an engineer, so be nice, okay? Several people have mentioned that Qt applications don't look native.
Mm-hmm.
So neither native Mac or native Windows. Why?
Why? Yeah, supporting native on Mac and supporting native on Windows can be challenging because Qt doesn't actually produce the widgets directly from the Mac. It's actually creating them or synthesizing them themselves. So as the Mac changes and as the Windows changes, the actual appearance can also change a little bit too. Yeah, it's I'm trying to get a demo, but I'm not doing terribly well because I'm finding it hard to see the actual application. So if we take a quick look at wrong one. If we take a quick look at a widgets application running on a Windows machine, calendar widget here. It's a lot of platforms to support, and we do, I think, a fairly good job of supporting most of them. So this is the calendar demo running on Windows. Give that a second while that's running. I'll completely not get my Mac running as well. Okay. Don't think I'm going to be able to get that to appear. So give that a second. Yeah, without going too deep into how Qt actually creates these widgets, they are synthesized and they are done as closely as we can get them. And I think most of the time we do actually a fairly good job. It's they're very, very close in most cases. Yeah, so that's mostly why this. You look at this widget application here. We have a bunch of, I think, reasonably good, reasonably close. So I would say that, yeah, on the whole, Qt does look quite right on desktop. Without going into too much depth, without digging through the source code to look more into it, then it's difficult to give a good answer. But yeah, we are synthesizing the buttons.
You try to make them similar. It's not a conscious choice to make them different.
No, we're not. They are as close as we can possibly get them. I haven't looked at the widget code for Windows recently. It's I think it's a fairly good job. So, yeah. Yeah, I can't get the Mac one to come up. It's not going terribly well. Okay, but yeah. I guess. Yeah, one moment while the microphone comes around. So do you mean an Android? It's this fellow here. So when you say Android app, what do you mean exactly?
Like a native app you develop in Qt, but you want to publish it on the Play Store for your customers. So,
okay, yeah, you want to publish an Android app created with Qt.
An APK file, so an Android package file you can publish.
As far as I'm aware, that works the same. I believe there are some Android apps, and I have distributed Android apps, but I've not actually worked with customers who are sending them to the Google Play Store. But yeah, it will work pretty good. Were you thinking of doing something else with the Android app, or just pushing it to distributing it? Yeah, the code signing for the Android should work the same as any other Android app. Okay. Do we have any more? 41. Okay, so I do have a talk upstairs, which I do need to get to, but we have time to look at anything else if anyone has anything else they want to cover. No? Okay. Oh, yes. No problem.
Yeah, you mentioned on one of the earlier slides that your customers met their return on investment numbers.
Yes.
Do you know what those numbers were?
Unfortunately, I don't. We didn't. This was the slide, I think, here. It was from a customer poll. So 95.3% of them met their expectations, but I don't actually know what their expectations were. Hopefully quite high. No. Okay, thank you very much for coming to the talk.